Computerized reasoning used to supercharge battery development for electric vehicles. Simulated intelligence battery concept. Utilizing AI, a Stanford Drove research group has cut battery testing times, a critical obstruction to longer enduring, quicker charging batteries for electric vehicles. New AI strategy from Stanford, with Toyota analysts, could supercharge battery advancement for electric vehicles. Utilizing another AI technique, a Stanford Drove research group has sliced battery testing times, a vital obstruction to longer enduring, quicker charging batteries for electric vehicles, by almost 15-fold. Battery execution can represent the moment of truth, the electric vehicle experience, from driving reach to charging time to the lifetime of the vehicle. Presently, man-made reasoning has made dreams like re-energizing an EV in the time it takes to stop at a service station an almost certain reality, and could help improve different parts of battery innovation. For quite a long time, propels in electric vehicle batteries have been restricted by a significant bottleneck: assessment times. At each phase of the battery improvement measure, new innovations should be tried for quite a long time, or even a long time to decide how long they will last. However, presently, a group drove by Stanford teachers Stefano Ehrman and William Chua has fostered an AI-based technique that slices these testing times by 98%. Albeit the gathering tried their strategy on battery charge speed, they said it tends to be applied to various different pieces of the battery advancement pipeline and even to non-energy innovations. A group drove by Stanford teachers Stefano Ehrman and William Chua has cut battery testing times, a vital boundary to longer enduring, quicker charging batteries for electric vehicles. In battery testing, you need to attempt an enormous number of things, on the grounds that the presentation you get will fluctuate radically, said Ehrman, an associate educator of software engineering. With AI, we're ready to rapidly recognize the most encouraging methodologies and cut out a ton of superfluous trials. The examination, distributed by Nature on February 19, 2020, was essential for a bigger cooperation among researchers from Stanford, MIT and the Toyota Research Institute that spans basic scholastic exploration and genuine industry applications. The objective: tracking down the best strategy for charging an EV battery quickly that expands the battery's general lifetime. The scientists composed a program that, in light of a couple charging cycles, anticipated how batteries would react to various charging approaches. The product additionally chose continuously what charging ways to deal with center around or overlook. By decreasing both the length and number of preliminaries, the specialists cut the testing cycle from very nearly 2 years to 16 days. We sorted out some way to enormously speed up the testing cycle for outrageous quick charging, said Peter Adia, who co-drove the investigation while he was an alumni understudy. What's truly energizing, however, is the technique. We can apply this way to deal with numerous different issues that, the present moment, are keeping down battery improvement for quite a long time or years. A more intelligent way to deal with battery testing. Planning super quick charging batteries is a significant test, mostly on the grounds that it is hard to make them last. The power of the quicker charge puts more prominent strain on the battery, which frequently makes it bomb early. To forestall this harm to the battery pack, a segment that records for an enormous piece of an electric vehicle's complete expense, battery engineers should test a comprehensive arrangement of charging strategies to discover the ones that work best. The new exploration looked to improve this interaction. At the start, the group saw that quick charging improvement added up to numerous experimentation tests, something that is wasteful for people, however the ideal issue for a machine. Simulated intelligence battery researchers. The examination group included, from left, Stanford professor William Chua, Toyota Research Institute researcher Muratahan Akol, Stanford PhD understudy Aditya Grover, Stanford PhD former student Peter Atia, Stanford professor Stefano Ehrman and tri-researcher Patrick Herring. Credit: Farron Abbott. AI is experimentation, yet in a more intelligent way, said Aditya Grover, an alumni understudy in software engineering who additionally co-drove the examination. PCs are far superior than us at sorting out when to investigate, attempt new and various methodologies, and when to adventure, or focus in, on the most encouraging ones. The group utilized this capacity for their potential benefit in 2 key manners. To start with, they utilized it to lessen the time per cycling test. In a past report, the specialists found that as opposed to charging and re-energizing each battery until it fizzled, the typical method of testing a battery's lifetime. They could anticipate how long a battery would last after just its initial 100 charging cycles. This is on the grounds that the AI framework, in the wake of being prepared on a couple of batteries cycled to disappointment, could discover designs in the early information that augured how long a battery would last. Second, AI diminished the quantity of strategies they needed to test. Rather than testing each conceivable charging technique similarly, or depending on instinct, the PC gained from its encounters to rapidly track down the best conventions to test. By testing less strategies for less cycles, the examination's creators immediately tracked down an ideal super-quick charging convention for their battery. As well as significantly accelerating the testing cycle, the PC's answer was additionally better, and considerably more uncommon, than what a battery researcher would probably have contrived, said Ehrman. It gave us this shockingly basic charging convention, something we didn't expect, Ehrman said. That is the contrast between a human and a machine. The machine isn't one-sided by human instinct, which is amazing yet at times misdirecting. More extensive applications. The scientists said their methodology could speed up practically every piece of the battery improvement pipeline, from planning the science of a battery to deciding its size and shape, to discovering better frameworks for assembling and capacity. This would have expansive ramifications for electric vehicles as well as for different sorts of energy stockpiling, a vital prerequisite for doing the change to wind and sun-oriented force on a worldwide scale. This is another method of doing battery advancement, said Patrick Herring, co-creator of the examination and a researcher at the Toyota Research Institute. Having information that you can divide between an enormous number of individuals in scholarly world and industry, and that is consequently examined, empowers a lot quicker advancement. The examination's AI and information assortment framework will be made accessible for future battery researchers to uninhibitedly utilize, Herring added. By utilizing this framework to streamline different pieces of the cycle with AI, battery advancement, and the appearance of more up-to-date, better advances, could speed up by a significant degree or more, he said. The capability of the investigation's technique broadens even past the universe of batteries, Ehrman said. Other huge information testing issues, from drug improvement to upgrading the presentation of X-beams and lasers, could likewise be upset by the utilization of AI streamlining. What's more, eventually, he said, it could even assist with advancing quite possibly the most central cycles of all. The greater expectation is to help the interaction of logical revelation itself, Ehrman said. We're asking, can we plan these strategies to concoct theories consequently? Would they be able to help us separate information that people proved unable? As we improve and better calculations, we trust the entire logical disclosure cycle may definitely accelerate.